Hello everyone, I am Noor Zainab and in today's video we're going to study that how we can derive the third equation of motion in an easy way. There are three equations of motion. We have derived the first and the second equation of motion in the previous videos, and in this video we're going to derive the third equation of motion. In these equations, the initial velocity can also be replaced by the letter u. So let's plot a graph between velocity and time. The slope of this graph, the slope of the velocity time graph gives us acceleration because acceleration is a change in velocity per time t. In order to find the slope of any graph, we have to divide the vertical component of the graph with the horizontal component. In this case, the vertical component is the velocity and the horizontal component is the time. So we can say that the slope of the velocity time graph gives us acceleration. Whereas if we have to find the area of this velocity time graph, in order to find the area, we have to multiply the vertical component with the horizontal component. If we multiply the vertical component velocity with the horizontal component time t, we get displacement or distance s. So we can say that the area of the velocity time graph gives us displacement, whereas the slope of the velocity time graph gives us acceleration. Now consider a car which is moving with some initial velocity vi, and after some time t, the velocity of the car becomes the final velocity, which is denoted by Vf. Because during this time duration, the velocity of the car is changed from Vi to Vf, we can say that the car has accelerated. If the initial velocity of the car is 0, then the velocity time graph will look like this. And because the acceleration is constant, the velocity time graph is a straight line. However, if the initial velocity of the car is not 0, it is some value of Vi, the graph will look like this. Here you can see the initial velocity as denoted by Vi and the final velocity denoted by Vf. In order to derive the third equation of motion, we should know that what is a trapezium. A trapezium is a quadrilateral, which means that it has four sides. Out of the four sides, two of the sides are parallel to each other. By being parallel, it means that these two lines never crisscross each other, they never meet each other. So the two lines are parallel to each other, and these lines are known as bases. And here you can see the formula to calculate the area of a trapezium. So now let's discuss a graph of a body which is moving with some initial velocity vi. After some time t, its final velocity is vf. In this case, the initial velocity is not 0, it is some value of vi. So now let's label the graph. The initial velocity is named as a and the final velocity is named as b. The slope is ab. If you see clearly in the graph, you can see a trapezium. The definition of a trapezium is that it has four sides and at least two sides are parallel to each other. So here in the graph, we can see that these two lines, it means OA and BD, are parallel to each other, and there are four sides, 1, 2, 3, and 4. Out of four sides, two lines are parallel to each other. So we can say that OABD is a trapezium. So if we find the area of this trapezium, we will apply the same formula, which is to find the area of the trapezium. And this area of this velocity time graph will give us the total distance s, which is covered by the body. As we have already studied before that the area of a velocity time graph gives us the distance. So by finding the area of this trapezium, it will give us the distance of the body. So let's put the formula to find the area of this velocity time graph. So in order to find the area of this graph, we will apply the same formula which is used to find the area of the trapezium, and this area of the trapezium will give us the total distance which is covered by the body. So the formula will be the half of the sum of the parallel sides. Here the parallel sides of the trapezium are OA and BD multiplied by the distance between the parallel sides. The distance between these two parallel sides is named as OD. So by putting these values in the formula, we get this equation. So now by bringing 2 in this side, we have to multiply it with s. Because here 2 is being divided, when it will come to the opposite side of the equation, it will be multiplied. So we get the equation 2s, which is equals to OA plus BD into OD. So now what we're going to do is that multiply both sides by BC over OD. So here BC is the change in velocity, which is from VI to VF, whereas OD is the time taken. We are multiplying both sides by BC over OD. After multiplying both sides with BC over OD, we get this equation. If you remember the formula of an acceleration, we can say that acceleration is the change in velocity divided by time taken. So BC is the change in velocity, which is final velocity minus initial velocity, divided by OD, which is the time taken. So we can say that BC over OD is equals to acceleration. So we are going to replace BC over OD by acceleration, and this OD will be cancelled with each other. Hence we get this final equation. So now by simply putting the values of OA, which is equal to the initial velocity, and BD, which is the final velocity, and BC, which is the final velocity minus initial velocity, we get this equation. If you look closely at this part of the equation, you can see that a mathematical formula can be applied. That a plus b into a minus b is equals to a square minus b square. So by applying this formula, we can get that vf square minus vi square. We can replace this part with this part. Here vf represents a and vi represents b. So by applying this formula, we get this equation. And this is the third equation of motion. This equation relates initial velocity, final velocity, acceleration, and displacement s. And always remember that this equation is always applied when the acceleration is constant. It means that the value of acceleration is always same. So now let's discuss that how this equation is converted into the free fall motion's equation. In free fall motion, all the objects fall with the same acceleration in the absence of air resistance, regardless of their masses. And this acceleration, which is constant acceleration, this is known as the acceleration due to the gravity, and its value is always 9.8 meters per second square. As acceleration is a vector quantity, in freefall motion, acceleration's value is always constant, which is 9.8 meters per second square, and it is always directed downwards towards the earth. In order to convert the third equation of motion into the freefall motion's equation, you have to replace acceleration with g, which is the gravity, and its value is 9.8 meters per second square, and s, or displacement, is converted into the h, which is the height. So in this way, the third equation of motion is converted into the free fall's motion. G is the gravity and h is the height from which the object is thrown downward. Thanks for watching, and like, share and subscribe to my channel for more videos. If you have any question regarding this topic or of any subject like biochemistry, physics, mathematics, etc., you can contact me via email or ask in the comment section. I will make a video on that topic. Thanks for watching.